friends. In this session of computer organization and design learning, today we are going to focus on register transfer language. So let's understand the agenda of this entire chapter first of all. So today we are going to cover the very first two topics, which are register transfer language and what is a register transfer. Then later on, bus and memory transfers, logic micro-operations, shift micro-operations, as well as arithmetic micro-operations are also part of this. So let's have a deep understanding of the register transfer language in detail. So before beginning with what is a register transfer language, it is very important to understand why we are learning the registers. Means what is its significance in the digital machine. So if you remember the digital systems, which we call them as a digital machine, right? So it is able to work with the digital circuits. Now, whenever we talk about the digital circuits, so there are two types of digital circuits which are very important to understand. These are the combinational and sequential circuits. Reason being, these two kinds of circuits are called as the building blocks of the digital systems, right? So, being it a building block, so that's why this is the basic requirement in order to design a digital machine. So, my point here is that we are lucky enough that we have already gone through the detailed part of the combinational circuits as well as the sequential circuits. We have also understood their applications, like we are using the combinational circuits in case of the adders, in case of the decoders, in case of the encoders, in case of the muxes, in case of the demuxes, right? And many more. Similarly, within the sequential circuits, we have also learned that flip-flops are the basic requirements which are acting as a memory element within the sequential circuits. And above that, we have also discussed about the resistors in detail. So today's session is just a detailed description of the resistor transfer language or the applications of working or the functionality of the resistors within the digital machine. So there are some basic reasons why we need to learn about the resistors in computer organization and design. The very first thing is that these digital systems which we are talking about, these systems are basically being characterized in the two ways. The very first way is the number of resistors or the type of resistors they are consisting of. And the second one is the type of operations we are able to perform on the data which is stored in these registers. So, for an example, if I say my machine is of 64 bit, right? So, what does it means actually? It simply means that the size of register that I am using for the instruction to pass to the machine is actually of size 64 bits. Means the register is of size 64 bits, which is able to take the instruction which is being provided by the users. So that is why within the digital machines, it is very important to understand the concept of registers. Later on, as we were also discussing that, what kind of operations now I can perform on this particular register. I will call those operations being the operation like a shift micro operation or being the operation like I am performing a count function, being I am loading a new data, any particular kind of operation, these all will be called as micro operations. So very important term to understand what is a micro operation. Micro operations are those operations which we basically execute on the data which is present in the registers which are available with us. So next point is now when we talk about the internal hardware organization of my machine. So within that internal hardware, we can simply say that the computer can be organized in basically three formats, right? There are three wayouts. The very first wayout is the set of resistors it is consisting of, right? How many general purpose resistors are there? what is the size of instruction register, what is the size of data register, and so on so forth, along with its functions. That is the first point, which is equipped or which is coming under the internal hardware organization. Second point is the sequence of micro operations it is able to perform. Now, the micro operations or the operations which I am able to perform on the data which is present in the registers can be like shift, okay, or it could be any logical micro operation, or it could be any arithmetic micro operation. We will be learning about these micro operations in detail in the later part of the sections. So the next third point is the control signals. These signals are very important to understand because these will initiate the sequence of micro operations that I wanted to perform. So the idea is that if I want to add the two numbers, let's suppose A and B, I cannot directly add them. There must be some control function being used which will be controlling the value of A and B and which will also control this operation to happen, right? So we will be learning about these control signals or the control functions in the later part of this particular session. So for the time being, let's only concentrate on what is the RTL and what is the significance of RTL being in the computer organization and design. So here is the case. As it has been saying, the name is that register transfer language. We also call it RTL, right? It is basically a kind of language. Language means a new technique would be it, right? Language is always having its own syntaxes and semantics, or you could say that the rules and regulations upon which it has been built. So basically, what RTL is a kind of language which we basically use while working with computers organization or its design. Okay, so let's understand in more detail about it. So basically, when we talk about the RTL, we are using the symbolic notations. If you remember in the previous video sessions, when I used to explain about a resistor, how I was designing a resistor with a rectangle, right? So I used to say that, okay, this resistor is consisting of some sort of data. Let's suppose this. And let's suppose this resistor is the name R. So whenever I am saying this, I am not writing the things in the word, okay? And by default, this particular mean of this resistor is that the size of this resistor is actually 1, 2, 3, and 4 bits. So my idea is that I am able to understand this only because of this symbolic notation. It is very easy for me or convenient method for me to write the things in the symbolic form rather than describing each and every micro operations using a simple word. Okay, so that is the thing. We are basically specifying the things in case of RTL in the form of symbolic notations rather than using any sort of wordings or the sentences that now register will be able to update its data or load its data. So how I am doing that? By the use of symbolic notations. So the next point is any function, for any function of the computer, the register transfer language can be used to describe the sequence of microoperations. So it could be fairly understood when we will be learning about these microoperations and how to implement them. For the time being, what exactly is RTL? RTL is nothing like a symbolic language. I will provide you more detailed description of these symbolic notations in the after one or two slides. Okay. So other thing is that it is a convenient tool for describing the internal organization of a digital computer in a very concise and precise manner. So, why it is able to provide me the data in a very concise manner is that for any particular resistor R, I need to just write it, design it with the symbol, this rectangular box, and just have to name it with the resistor R. So I need not to write it in the form of sentences that, okay, this is a resistor R which is of specific number of size. I need not to do that. By the symbol only, it is itself depicting the meaning. Okay. So it can also be used to facilitate the design of the digital system. So definitely, as I was asking, I was explaining you before, where we are using this RTL we are using it in the computers organization and its design. So this is where we are using it. We are using the RTL. So let's understand more about the RTL. Like as I was explaining earlier, we are using the symbolic notations, or how we are using that symbolic notations. So let's have a little demonstration of those ideas. So registers are designated basically. So this is the rule actually. RTL is having certain rules and regulations. Okay. So registers, what we can do is register are being always classified with the capital letters. Like this is we can also name them with any particular alphabetical name or along with the numeral also. Along with that, the register can also be defined based upon its functionality. Like if this is MAR, a kind of register, I would be saying it is a memory address register. If it is a PC kind of register, it is a program counter register. If it is an IR kind of register, it is nothing but the instruction register. So idea is very simple here, that the registers are basically being designated with the capital letters. And how we can use these letters? These letters can be any alphabet, okay, any capital alphabet, right? It should be capital, it is very important to understand, or alphabet plus numeral also, like it has been described here, R13, R2, R3, something like that. Along with that, there is one more combination based on the functionality, like why or the purpose why we are going to use it. Okay, like again I am saying, if my system is able to take 64 bits data at a time, it means the instruction size is actually of 64 bits. This is what is the meaning of the term when I am saying the system is having the ability to work with 64 bits. Okay, now the next is that registers and their contents can be viewed and represents in the various ways. So definitely, how we are able to understand that it is a register and what is the content available within the register? There are number of methods being used. The very first is that we can also use it as a single entity like this. I am designing, I have simply designed a rectangular box, and along with this particular box, I have just named this particular register. It is a memory address register. Whenever I need to refer any of the data within the memory, so how I could refer that? First of all, I need to get the data, which address value, which is present in this register. Similarly, whenever we are designating the register, right? So how I can designate that? Designation simply means in RTL how I can demonstrate that this is a register or this is any specific part of a register. So there are two, three or four methods being provided here. The first thing is the simple register. Register R1 it is, okay. I have not actually mentioned the size here. So size I cannot determine just with this name. The second thing is that by showing the individual bits also, right? So this is the least significant bit. Always, this is the case. It is never the case like 0 will start from here and it will move towards this. No. Always the least significant bit will present on the right hand side and the most significant bit will be present on the left hand side. So this is the rule of RTL again. The next point is I can also demonstrate the register with its name as well as the size of register like this. It is starting from 0 till the 15 values. So based upon the number of bits also I can define a register. Again, I can also define a register by demonstrating the portions of it. So what I did is I simply divide this register into two parts, or you could say that these are the two subfields, right? So this is a register with the name program counter, and this is the least significant bit, and these are the highest number of bits. The most significant bits are present in this side. LSB is present on this side. So my idea here is that within the RTL I will be telling you in detail about the registers and how I can designate the register, right? And the functions or the operations that I am able to perform within the resistors. So this is what we will learn in the RTL. Along with that, we will also learn the rules, the syntaxes, the symbols that we are using to demonstrate the resistors for a within a specific situation. So here is the another thing. Now now the next part is there, which I am calling it as a resistor transfer. So the key term is the resistor transfer. Resistor transfer means whenever I want to copy the contents of one resistor to the another. So the idea is that, let's suppose there is a resistor with the name R1, and I want that this entire data which is present in R1 should be present in R2. So how I would be able to do that? This entire operation of transferring the data from this source resistor to this destination resistor R2 is called as resistor transfer. Okay, so how we are defining it? This symbol will define that this is a transfer symbol, you could say that. So if this has been provided here, it means that the data which is present here in this R1 resistor, which is also known as the source resistor, is actually being copied into this particular resistor, which is called the destination resistor. So this particular symbol is showing me nothing but the direction of flow or the transfer of data. So this is the another key term or the symbol which we are using in the RTL. Okay. So what we are doing is, in this case, the contents of resistor R1 are copied into the R2. Simultaneous transfer of the bits from the source R1 to R2. So definitely we know that each and every resistor, let's suppose this is a resistor having the bits A0 and A1, it is R1, and want to send its data here, right? So how this transfer will take place? These will be attached by the clock signals. So, and within the signal, all the data will be parallelly transferred into this whenever the next clock pulse will arrive. So this is again important thing. The data is always transferred in a parallel mode. So this is the another property. It is a non-destructive kind of system, right? So this property is that the contents which are present in R1, let's suppose again, these all are two are the contents A1 and A2, A0 and A1, right? Which are available within the R1. I cannot change the value like instead of A0, if I am using any new, let's suppose data, which is let's suppose Q0 and A1. This is what I cannot do while transferring the data. So this is non-destructive. The R1's content are not altered by copying the data. Okay, so this point is important to understand. Furthermore, I can define the resistor transfer in such a way, right? So it simply means that, as I was explaining you before also, the R5 resistor, being the source resistor, is able to transfer its data to the destination resistor, which is nothing but the R3. The second point was the data will be loaded parallelly to the destination resistor. Third line will be there will be some control lines being used. So how I am controlling this operation? Any micro operation that we want to perform on the resistor will always be controlled by the control functions or the control signals. So this is something which is very important to understand. Even if I'm writing it here like R5 is transferring the data to R3, but exactly it is not the same. So let's understand about these control functions now in detail. So this is what is the control function. So control functions simply depict the meaning that often the actions need to occur only if a certain condition is true, definitely, right? So if you remember, in the programming languages we are using the if statement. Like if any particular situation is true, if A is greater than B, only then what to do is, then you can perform a specific operation, only then I can add A to the B, something like that, right? So the condition is this: until or unless this A is greater than B, I cannot perform this. So same is the case here. So it is very similar to the if statement, these control functions. right? So how it is working? So again, this is the demonstration present here. R1 wants to transfer its data to the R2, but when this transfer will take place, if this control function will be satisfied. Okay, so let's understand in more detail about this particular statement's meaning. This statement means that if p is equals to 1, this colon means it is a control function. It is depicting that now the control function is this, and this particular value says that now the control function has ended, right? So this column says if this particular thing which is present on this side, it could be anything. It could be any logical micro operation also. Anything can be present here, right? So if the colon is present, it means this entire thing is nothing but a control function. So I have tried to simplify it with very simple example. If p is equals to 1, p is alone here, it means I want this value to be equals to 1. Then what will happen? Load the content of R1 to the R2 resistor. Only then the data present in this R1 will be loaded to this R2 kind of resistor. So this is what will happen. So again, in a simple less meaning, so this is what this particular equation is representing. If p is equals to 1, then R1 will be transferring its data to the R2. So let's understand in more detail about how the hardware implementation of this control function will work. So here will be a control circuit, means the control circuit of this. So accordingly, what I need to do is there are two resistors that I need to take. So what I want to do, I want to transfer the data of R1 to R2, right? So that's why this arrow is like this. And this N are the number of bits or the size that I want to transfer on this particular R2 resistor. So idea is that all these things are actually connected together via a single or a common clock pulse, which means that as soon as the condition will met, as soon as the p will become equals to 1, what I need to do is I will be transferring the data on a parallel go from R1 to R2. So the idea is simple this: whenever the load will be high, the transfer of the data will actually takes place. Okay, so this is how the control functions work, and this is how the hardware implementation of these control transfers can be taken care. So this is the point, which is the last one. So you could say it is the summary of what we have learned so far. There are some basic symbols within the resistor transfer. Okay, let's understand them. So we are using capital letters and numerals to denote the resistor. Definitely. So I am saying R1 is a resistor, R is a resistor, PC is a resistor. So these all are the resistors. This is how we can designate a resistor. The next thing is the parentheses. Parentheses are nothing but whenever I have to depict any specific part of the resistor, then what I will do is I will simply represent it in these parentheses. Okay, this 0 to 7 means the size of this resistor is actually 8 bits. This means it is showing the least significant part. Then there is an arrow. Arrow is nothing but which is denoting the transfer of the data or the flow of data. So basically, it also represents the direction in which the data is getting transferred. The same is the case with this colon also. Colon is nothing but it will determine that the termination of the control function is there. For example, like previously I was using this. So whatever I am having on this side, it means that is a control function. Whenever this colon will arrive, it means the control function ended, and then the whatever the operation I want to perform, I will be performing them. Okay, then the same is the case, the comma is there. Let's suppose I want to transfer the bits like this: r1 to r2, comma, r3 to r4. So how I can do that? I can separate these two operations with the comma also. Means instead of writing it on the another line of the code, I can write it in the one single line of the code also. So let's suppose this is how this control function will work. So for both R1 to transfer to R2 or R3 to be transferred to R4, What I need to have is I need to have this control function to be met. Only then this transfer will take place. So, with this, I hope that you have understood the entire lecture. So, if you have any doubt, you can write your question in the chat box. Thank you so much.